In this video we're going to be looking at some common tools used in the metalwork room. Things like the scriber, dividers, odd leg calipers, a punch, dot punch and centre punch, the hammer, T-square, ruler, hacksaw and also the bench vise. You're going to see a clip of video on each one of these tools, and then afterwards you're going to see a slide with information that you really need to know about those tools. What I'd like you to do is to make flashcards for each of the tools, and I'm going to show you how to do that now. So I have here a sheet of A4 paper. This is probably too big for a flashcard, so what I'm going to do is I'm going to cut it in quarter. I'm going to quarter, so I'm going to half it first, just by folding it over, get the edges flush, and then using a scissors in my wrong hand, I'm going to just cut down the crease there. And then I'm going to take these two halves and fold them in half again. Now obviously you could do this a fair bit neater, I'm just trying to give you an idea. I think I might use my normal hand for my normal setup. Okay. So basically this is around the size that a flashcard is. And a flashcard is just a card that has a small amount of information on it that you can stack through quickly. So the first tool that we're going to look at is the scriber. So I'm going to write that down. And I might give it a little bit of colour to make it stand out. And on the slides you're going to see after each section are going to be a number of facts, and you should write those down as well on your flashcard. So you might do something like this. There's more points than this. But now you'll be able to use that and your other flashcards, and you'll be able to look through them quickly. So I'd be able to come along and see scriber, made from high carbon steel, point angle 30 degrees. Move on to the next tool, which might be hammer, made from high carbon steel, handle made of ash. And I can test myself using these as well. I can look at this for a couple of seconds, turn it down, try and remember what was on it, check. So flashcards are very handy and can be done for a lot of subjects. Okay, so let's get on with the video. The first tool we're going to look at is the scriber. Okay, the first tool we're looking at here is the scriber. The scriber is a tool used for marking out or scratching the surface of materials. It's made of high carbon steel, and that's because it has to be harder than the materials it scratches through. This one is called a double pointed scriber. So you have your point here, and this part can be used for getting in under surfaces. So if we needed to get in and scratch underneath here, we mightn't be able to get at it from this angle, but we might be able to do it like this, and that's where that'll be used. But generally we use it like a pen in this fashion. The point angle, the angle that the point makes, so if you look at, that's the point angle where my thumbs are in the middle, for a scriber should be 30 degrees, and you can regrind that if it gets blunt. This section here is knurled, K-N-U-R-L-E-D, so that you have a better grip on the scriber when you're using it. If it was just smooth surface, it'd be quite easy for it to slip maybe when you were using it, but when it's knurled it makes that a lot more difficult. It's made from high carbon steel, which is an important thing to remember, because high carbon steel has to be you have to use a hard enough metal so that it scratches. So we can scratch a piece of aluminium here quite handily. This is some Perspex, scratches that no problem. Another piece of aluminium, but thicker, and hopefully you can see the scratch marks in that. You should be able to see them. This is a piece of mild steel. and we can scratch that quite effectively. But we do have to put a bit of pressure on it, but it is scratching the material, and there's no damage done to the tip because this is harder than that. Now this is a piece of high-speed steel, this drill bit here, and the scriber is softer than this. So when I scratch, all it's doing is taking off that black paint, or the black surface that covers. It isn't actually making any scratch in the surface of the metal, it's just getting rid of this black material. You can see it here as well. It's sliding over the surface, not digging into it. If we go back to a regular piece of steel, you can hear the difference in it. It is actually scratching into the surface. So high carbon steel is used in a scriber because it's harder than most other things. Now the one thing, you usually use a scriber in conjunction with something like a T-square or maybe a ruler. And in these cases, one thing to watch out for is when you're scribing a line, you want to scribe in like this. You want the point to be going into where the ruler and the surface meet. So we want to scribe like that. It's a bad habit to be scribing over the edge because you're not actually going to be hitting. The point is going to be further out. Another little tip, sometimes it can be very hard to see a scribed line on some coloured surfaces, like silvery surfaces. Get a marker, colour in. You can get special bluing compounds as well, but markers work quite well. And that should enable you to see the scribed mark a little bit clearer. So that mark should stand out a fair bit more than the one here beside it that's running down here. Alright, so that's the scriber. The next section is going to be a slide. Pause that slide and take down the information on that. Alright, the next tool we're looking at here is the ruler. Very simple device. We use in Ireland and in a lot of the parts of the world we use the metric system. So that means we use millimeters, centimeters and meters and kilometers to measure distance. In England and America, a lot of Americans, they use the empirical system, which means inches and feet and miles, etc. It's handy to have a comprehension of that, but you're going to be working in millimeters and the metric system the whole time. So this ruler here shows 10 millimeters, and there are 10 millimeters in a centimeter. So this long line represents centimeters. So this will be 4 centimeters, 8, 14 centimeters, 230. The shorter ones in the middle then are 5 marks. So that would be 65, 85, 155 millimeters, or 15.5 centimeters. And then down here, the small ones are all the millimeter sections. So in the case of here, this one here near my point, the scriber will be 44 millimeters. It's one short of 45. Some rulers you will get, not this one, will also have maybe for the first 50 or 60 millimeters, they'll have half millimeter sections. And they can be quite difficult to see, so you need to be careful when you're looking at them. Rulers should be taken care of. They're made from high carbon steel because you're going to be rubbing hard tools up against them when you're drawing lines, and you don't want to damage this. You don't want to be bending them. You want to have a straight edge here, and you don't want to be hitting the sides of them. Okay, they should be taken care of. You can get them in different lengths. You can get them long like that. And if you find that your ruler, in this case a 300 millimeter ruler, isn't long enough, you can always get something like this, which is a tape measure. Now tape measures usually have, sorry, turn around the other way. They usually have the empirical system up here and then the metric system on the bottom. But this one is a small one. I think it goes to about 3 meters in length. But they're handy and they can help you with longer lengths. In this section we're going to look at this tool. This is properly called the engineer's tri-square, but we usually call it just a T-square. The T standing for tri in TRY in engineer's tri-square. It's actually made up of two parts. This part is the handle that you hold, and it's made from mild steel, and we call that the stock. And this section here is made from high carbon steel, and it's called the blade. And this is the actual surface we mark against. T-squares have two purposes. The first purpose is to check if something is square. So I can bring up my tool and I can see very clearly here. So I've got the edge here up against the stock, and I slide it up to meet the blade. And I can see very clearly there's a gap at this end. This is not square. If I turn it over and look at the other end and slide it up, you can see that the piece of metal meets the blade the whole way across, and therefore it is square. The second purpose then is to draw lines perpendicular to an edge, and perpendicular means at right angles to. So we want to draw a line with our scriber straight across, perpendicular to this edge. So we bring up our T-square, make sure the stock is up against the metal, sliding along it there, and then with our scriber we can T-square a line across. And we know that this line here now is at 90 degrees to this edge. If we look at a T-square like this, you can actually see there's a gap here between the blade and the bottom. This means that if the material is thick enough, such as this piece of steel is thicker than that gap, we can do that on a surface. So we can sit it down like that. However, if we look at this piece of metal, this is 1.5 millimeters thick, it is clearly a lot thinner, and therefore we can't sit it down, because what will happen is you'll end up with a gap under here. You need to pick up thin pieces of material before you use them, and you need to be careful that you don't have, and I'm exaggerating this here, you don't have the stock at an angle to the piece. Always make sure it's up against the edge and slide it up to where you want to do the line. The last thing I want to note here is this. This is a little notch in the stock, and it is in case you're filing something. Do we have a piece here? We just have a piece of metal sticking out here, and it's called a burr, B-U-R-R. And we can use that. That can go into the notch if we need to measure something or check it for perpendicularity or to draw a line. The notch is just a place for little things like burrs to go. So that's the engineer's tri-square. The notes will be up in a sec. Next we're looking at the punch. Now this doesn't affect you too often, and probably won't for most of your time in Riversdale, but there are actually two types of punches. The fact that these appear differently in terms this is gold and it's bigger, and this one has a square head and it's knurled, that doesn't matter. The difference is actually these angles here at the top. Now I'm going to try and zoom in. Hopefully we might be able to notice the difference. That's about as close as I can get, I think. Hopefully that's focused for you. Now the angle on this one is 90 degrees, and the angle on this one is 60 degrees. It should look a bit pointier. I'll try and bring them closer. It should look a bit pointier. This is actually called a dot punch when it has an angle of 60 degrees, and it's called a center punch when it has an angle of 90 degrees. Sorry. Now, they actually have two different purposes mostly in metalwork. The center punch is used for when you want to drill a piece afterwards, so you center punch where you want to drill and then go drill it, or maybe if you wanted to use a dividers or something like that to draw a circle so that the point wouldn't slide around the surface. The dot punch is usually used to mark the edge of a surface, or where you're going to be filing down to in a piece of metal. We don't use it for that so much anymore these days, but sometimes that can be handy. Generally we use these interchangeably. They're made of high carbon steel. The surfaces are usually knurled so that you have a better grip, or in the case of this one, it's octagonal, so that you have a grip. You can actually feel that. It's not going to turn in your fingers. When you're hitting them with a hammer, always use the flat end of the hammer to hit them. So you hit them like that. Do not hit them like this, because you might accidentally slide off and smash into your own fingers. Like all tools, you should take care of them. You don't want to be damaging the points. They can be reground, but that's time and effort that doesn't need to be done. So that's the punch. The dot punch, 60 degrees. The center punch, 90 degrees. Here we're looking at a dividers. We're looking at two actually. Dividers can come in different sizes. You can get smaller ones than this, you can get very small ones, and you can get bigger ones than this. They're basically the same. They have two main functions in engineering, and that is to draw circles or to draw arcs. They can also transfer distances. So we could, for example, see what the distance is. There's two scratch lines here and here. We could get the distance there between those, and then using a ruler we could tell what distance that was. It's about 41 millimeters. They have a screw here for loosening and tightening, so I can screw it out and screw it in, and it will make the points closer together. Sometimes that's very slow, especially if you have a long way to go. You can squeeze the points and spin this around much faster without it being loaded, and then let go and adjust it. This is a spring, this section up here. Be careful when you squeeze it, because if you let go, it can jump out very fast and it may pull it out of your hand. I knew what I was going to be doing there. It wasn't going to be a surprise. These parts here, the legs, are made out of high carbon steel because these points need to scratch other materials, and you want to protect these. These shouldn't be banged into anything or dropped, because these points need to be level, meeting each other in order to work effectively. When you're using a ruler, I find the best way is to put the point on something like 10 millimeters rather than trying to use the end of the ruler and then setting it to the distance that you want. So I want to set this to 30 millimeters, for example. So I'm going to set it, put one point on 10, and then I'm going to tighten up to 40. That means, and I'm adjusting it now, that means there's 30 millimeters between the points. But if you try to use the end, you may actually slip off. It's much easier if you can put the mark there, this section there, or sorry, the tooth there. Dividers can actually, and were used a long time ago to actually do division in maths. And that's where they kind of get the name. Okay? Right, the notes for that will be coming up shortly. This is a ball peen hammer. The ball peen hammer is the hammer that most metal workers use, and it's called a ball peen hammer because this end here, the end away from the flat end, that's the end you'd normally hit things with, this is called the peen, P-E-I-N, and this is a ball shape that we use, and it's used for things like riveting and hollowing in metalwork. In woodwork you might be familiar with the claw peen hammer, which has the claw here that curves out and is used for removing nails and things. And you can get other types of peens on hammers as well for different purposes. If you wanted to buy a hammer, it's the weight of the head that you buy a hammer by. That's how it's classified. This is a 12-ounce hammer, so that head weighs 12 ounces, and that's how you purchase them. The handle that comes with them has to be made of a reasonably good shock-absorbing wood. So in Ireland we tend to use ash more often than not. In America they don't have that many ash trees. They use a wood called hickory. It has very similar properties, very good at absorbing vibrations. The head is made out of high carbon steel. Again, you're going to be hitting hard tools and you want to dent softer materials, etc. So that's why it's made out of that. Don't think there's anything else? Nope. This tool is called an odd leg calipers because the two legs are odd. Sometimes it's referred to as a Jenny. I think that's kind of an old name for it, as in the girl's name Jenny. But we usually call it an odd leg calipers. It's a very, very versatile tool, and it's a very handy tool. You'll use it with a ruler. So we want to set our distance between this corner here and the point. So I'm going to set 30 millimeters on this. So I'm going to put the ruler into the corner there, and then looking at my numbers, I'm going to bring that out to 30 and adjust it until I'm happy. We now know that between that corner and this point, there are 30 millimeters. So if I get a piece, I can draw a line. Now notice where I'm holding it. I don't want to hold it here because I don't want to make the gap different. I'm holding it at the edge and putting the corner of the odd leg here, and I'm going to scribe a line down. Now this isn't very visible to you, I would say, but I've just done a line here. You should be able to see that. And we know that that line is 30 millimeters from this edge and parallel. And I could do another line down here. And now I have two lines 30 millimeters from the edge. So it's very handy for doing lines parallel to an edge on any material. It's also very handy on the lathes. So this is a piece we could have on the lathes. I could be holding it in my chuck here on my left hand, and I could use the odd leg calipers like that, and as it's spinning, scratch a line in the surface 30 millimeters from that end. Very versatile tool, very handy, and it's called the odd leg calipers. Before I go, this is the scribing bit, and it's actually removable. We can loosen that nut and take it out because we want to be able to adjust it so that the height here and the corner are the same. This is made from high carbon steel, so that it will scratch softer materials, and then the rest of it is made from mild steel, so that it won't damage anything else. So that's the odd leg calipers, or Jenny. Here we have the senior hacksaw. This is basically our main cutting tool for different materials. The blade is removable, and you can replace it obviously when it gets chipped or worn down. Blades usually tell you two important pieces of information. Number one is the direction that it should be set to, and the arrow points that way, so that should be pointing towards the front of the hacksaw, so it should go in like this. And also the number of teeth per inch. So I'll bring this up closer for you to see. So you can see there it says 24 TPI, that means 24 teeth per inch, or 10D, and that means 10 teeth per centimetre. It also tells you the length of it here, 12 inches, or 300 millimetres. These blades are actually often nowadays made, they're bimetal strips. They're often bimetal strips, which you can see there. And the reason for that is the teeth are hardened so that they're harder than other materials, but the rest of the blade wants to be flexible so that it won't snap if it's bent by accident. The senior hacksaw, they're adjustable. If you buy different length blades, you can actually move this screw hole up to here, moving the handle, making it a little shorter. And they're much, much bigger than a junior hacksaw. And they have different purposes. This is the one you should be using most often. The junior hacksaw should only really be used when you're in small places or working with thin material. Now, one issue you may have with the senior hacksaw is if you're trying to cut a piece of material such as this. If we wanted to cut a line down this way, the hacksaw can only go a certain amount of way down before the piece of metal will be hitting this bar at the top. And that's a problem, because how do we go the rest of the way? What you can do is you can loosen this wing nut here. This is the tensioning nut, and normally when we're putting it, we always check and make sure that's tight, but you can take that off and you can actually turn a hacksaw blade around. Sorry, that was causing a light problem there. You can turn the hacksaw blade around so that it's at 90 degrees to the frame. Now, if we want to hacksaw down, that seems to be causing. Now we can keep hacksawing down the whole way down the material. There's nothing to stop the blade moving down the whole time. So that's the hacksaw. If you do change the orientation of the blade from normal to this way, please turn it back before the next person has to use it. Okay, notes coming up on the hacksaw there. Okay, here we have a bench vise. Bench vise is called that because it's a vise and it's attached to the bench. This is its fixed part, so this section here is screwed to the bench, and then this is the movable jaw, so when we turn the handle it can go in or out, and that allows you to squeeze things and hold them for working on and hacksawing. These jaws here, the hacksaw or the bench vise itself, the body is usually made out of cast iron because cast iron is very good at absorbing vibrations, and these jaws are removable. The jaws are made out of hardened steel so that they'll grip things, and they've actually got serrations on the surfaces here. I'm going to try and zoom in on those to see if we can get a better look at them. So you should be able to see there the lines going through the material, and that gives these jaws teeth for gripping onto something. But that's a problem if we have something soft like this aluminium here. So if I squeeze the aluminium and I tighten into it and I do some work and I take it out again, see if we can get this in focus without blinding everyone. You may not be able to see it very clearly, but there are little marks left in the surface here of the aluminium by the serrated teeth. The way to overcome that is with soft jaws or vice jaws. So here we're using just 2 pieces of aluminium because aluminium is a soft metal, and now when we grip something it won't damage it. You can purchase soft jaws as well, but they tend to be quite expensive at times. So that's the bench vise, made of cast iron, used for holding things. Well, that's that. There are many other tools that we have in the metalwork room, and we'll look at those at a later date. But for now, that's it for this video and for today. So I hope you've learned something, and thanks for watching.